Okay, so to pick up where the last video ended, said we were going to do an explosion example. So we have a 30 kilogram object, so the total mass of the object is 30 grams, not 30 kilograms. That could kill someone if it explodes. So a 30-gram object explodes into 3 pieces. One piece of mass 7 grams goes off at an angle of east 40 degrees north. So here's piece 1, and it goes off east 40 degrees north. So if I draw my x-axis out here, east north would be this way. So it's going up here. And it says this piece is 7 grams. And so V1, and it says it goes at a velocity of 42 meters per second. This really could hurt somebody. Okay, and this angle here is 40 degrees. So of course there's going to be an x component and a y component, but we'll come back to that in a second. The second piece, 12 grams, goes off at an angle of west 21 degrees north. So here's my negative x-axis. West 21 degrees north is going to be this way. And so this is piece 2. And it says piece 2 is 12 grams. And it says this angle is 21 degrees. And it says V2 is 33 meters per second. And then the question wants to know what's the mass and velocity of the third guy. Well, the third guy is going to go somewhere down here. Now, if it's right or left, we're not sure. So you can just pick one. The math will tell us which way in the end. So this is going to be V3F. Oops, I just ruined the next part of the question. I was about to ask, are these VFs or VIs? Originally, it's all sitting here as one whole piece minding its own business. All of the VIs are 0. These are all VFs after the explosion. This guy's 7 grams, this guy's 12 grams, so what must 3 be? The total is 30, 7 and 12 is 19, so 3 should be 11 grams. So the question says, 30-gram object explodes into 3 pieces. One piece, mass 7 grams, goes off at an angle of east 40 degrees north, velocity of 42 meters per second. A second, mass 12 grams, goes off at 33 meters per second, west 21 degrees north. What is the mass and the velocity of the other? Okay, so we're looking for this. So we already found the mass. Now what we need to find is V3Fy and V3Fx. We have the info to get V2Fx, V2Fy, V1Fx, and V1Fy. So we're just going to do x and y directions momentum again. So in the x direction, initially it's all together, m1 plus m2 plus m3, v initial x. And that's going to equal m1 v1 final x plus m2 v2 final x plus m3 v3 final x. Now, this whole side is 0 because initially it's not moving. And I would highly suggest before you rearrange, look after your directions, because look, V1Fx is going one way and V2Fx is going the other way, and you don't want to screw up your signs. So assuming that we call to the east positive, then this will be M1V1F, and that's cos theta 1. And this one's going the opposite way, so minus M2V2F, and that's also cos theta 2. We're not sure which way M3 is going, so don't just leave it as is, as positive. If it's going in the opposite direction, it'll work out to be negative. If it's going positive, it'll work out to be positive. So on your unknown, just leave it as positive. And now rearrange. So I would take these two terms over. So I'd have V3Fx is equal to M2V2F cos theta 2 minus M1V1F cos theta 1, and keep your subscript so you can keep track of what number you're filling in where. And this is M3. So V3Fx. Now, do I need to change my masses to kilograms? I could divide all these by 1,000, but I really don't need to because I'll get the same answer even if I don't. So M2 is 12 grams, V2F 33 meters per second, and the angle of 2 is 21 degrees, minus M1 7 grams, 42 meters per second, and the angle for 1 40 degrees, divided by 11 grams. So V3Fx is equal to 13.135 meters per second. So this is my x component, and it works out to be positive, which means really it's going this way. Okay, so the way I drew it up there wasn't accurate. All right, now we're ready for y. So M1 plus M2 plus M3 V initial Fy is equal to M1 V1 Fy plus M2 V2 F. Oh, that's what's screwing me up. There's no initial there, it's just F. Y plus M3 V3 F. Oh, there's no final there. It's just the I. I knew something's messing me up there. F, Y. Okay, again, doesn't matter what I call this side because it all goes to 0. And again, before you rearrange, fill in your things and look after the signs. But this time, in this case, both of my y components that I know are going up. And so it will be positive M1 V1 F, and it's going to be sine theta 1 plus M2 V2 F, and again sine theta 2, and then plus M3 V3 Fy. Solving for M3 V3, actually let's just solve for V3 Fy. So negative M1 V1 F sine theta 1 minus M2 V2 F sine theta 2 divided by M3, and then fill in your values. So V3 Fy will equal negative M1 was the 7 grams, 42 meters per second, sine of 40, minus the 12 grams, 33 meters per second, sine of, what was it, 21, divided by 11 grams. V3Fy is equal to negative 30.081 meters per second. And the negative's no surprise, means it's going down opposite the other two, which it should be. Okay, so now we're going to go up here, and we'll just draw it here on the side. So you have this one going down, which is 30.081 meters per second. And you have your x going over, which is 13.135 meters per second. And so you're going to square them, add them together, take the square root, and find this angle. And when you do, you should get a V3F of 32.824 meters per second. And this angle is going to be south. I found the other one, so now I have to do math. South 23.578, maybe 588 degrees east, or east 66.412 degrees south. Either of those are accurate. Okay? So now for homework tonight, I would like you to do the question, or when you finish this video, I'd like you to do the first two questions on this sheet. And on page 513, there's one question there, number 38, and the first two on this sheet. Okay? Tomorrow we'll do, or the next video we'll do elastic and inelastic collisions. So 1 and 2 on this sheet.